Okay, let's have a look at some results. So this is our P and S wave graph, and this is our seismograph. If we measure the time interval then for each of these sites, these are the type of numbers you should get. If you're a little bit out, it's fine. But for Tonopah, there was a time gap of about 24 seconds. For Pasadena, that time gap was 38 seconds. And at Cedar City, the time gap was 62 seconds. If I take those times and put them on the P and S wave graph, Tonopah there, that 24-second gap fits in about there. And that's a distance of about 205 kilometres from the epicentre. There or thereabouts. For Pasadena, at 38 seconds, we're a bit further away because the gap is bigger. We're a distance there about 315 kilometres. And finally at Cedar City, the furthest away, a gap of 62 seconds is out there, and that's about 475 kilometres. So we now know how far this earthquake epicentre was from each of these three stations. What we don't know, of course, is in which direction those waves have gone from the epicentre to each of these places. So to work out where it is, we need to look at our map with the three locations. And we then need to draw three circles. We know how big the circles are because we've just measured it from the graph. So from Tonopah, we've got a circle that's 205 kilometres in radius. From Pasadena, we've got a circle that's 315 kilometres. And we can now see that there's an area here where those two circles overlap. But because there's an area there, and perhaps two places where those circles actually cross each other, it's not pinning it down quite accurately enough. For that, we need a third circle. So from Cedar City, we draw our last circle, this time radius of 475 kilometres, and we've got a place there where those three circles overlap. That is our epicentre. Now have a look at your atlas. Where is that place? What type of problems might be caused in that location? Think about what that place would be like. It is a place marked on the map. Okay, it's in the Death Valley area of California. What problems would that cause? What type of place is that likely to be? Now, part of the way of assessing how big this would be by working out how big the earthquake was. What's its Richter magnitude? And to do that, we use this graph. This is for those of you that dug a little deeper into this. You can work out the size of the shaking or the amplitude by looking back at the seismograph data on page 6. We know the distance from each of these places to our earthquake. So if we then join up a line from the distance from the epicenter to our seismic station to the amplitude, so the amount of shaking, either above zero or below zero for the S wave, we'll get a measure for its magnitude. Draw the lines across and see where they meet in the middle. Have a go at that now. Okay, if we have a look at this, at Cedar City, we didn't have much shaking at all, an amplitude of less than 10 millimetres. But it's 475 kilometres from the epicentre. At Pasadena, we're just over 300 kilometres, and the shaking's a little bit more. It's just over 20 millimetres of shaking. At Tonopah, the closest one, we're getting nearly 100 millimetres of shaking. So you can see those three lines there, all crossing in the same place on our magnitude column. So the earthquake there has a magnitude of 5.5. What do we think? Is that a big earthquake? A small earthquake? A medium one? How much damage is that likely to cause, particularly to a place like Death Valley? Okay, as the sun sets on Death Valley, think about what all these graphs show us about the nature of earthquakes, about how much shaking there is, about how much warning we could possibly get if we knew that earthquake waves were on the way. What does that tell us about the hazards that these events create? Next time, we're going to have a look at the shape of the Earth's surface. I'll see you then.